will continue the session.
தேசிய கொடியும் அசைந்து சொல்லும் கலாம் கலாம் சலாம் சலாம். தேசம் முழுக்க எழுந்து சொல்லும் கலாம் கலாம் சலாம் சலாம். கலாம் கலாம் சலாம் சலாம். கலாம் கலாம் சலாம் சலாம். தேசிய கொடியும் அசைந்து சொல்லும் கலாம் கலாம் சலாம் சலாம். தேசம் முழுக்க எழுந்து சொல்லும் கலாம் கலாம் சலாம் சலாம். கல்லும் முள்ளும் புல்லும் சொல்லும் கலாம் கலாம் சலாம் சலாம். காலம் கடந்து காலம் சொல்லும் கலாம் கலாம் சலாம் சலாம். கலாம் கலாம் சலாம் சலாம். கலாம் கலாம் சலாம் சலாம். முழுக்க எழுந்து சொல்லும் கலாம் கலாம் சலாம் சலாம். கல்லும் முள்ளும் புல்லும் சொல்லும் கலாம் கலாம் சலாம் சலாம். காலம் கடந்து காலம் சொல்லும் கலாம் கலாம் சலாம் சலாம். கலாம் கலாம் சலாம் சலாம். கலாம் கலாம் சலாம் சலாம். தேசிய கொடி
A very warm evening to all the dignitaries, our beloved guests, respectful faculty, and the passionate seekers of science joining us from every corner of Bharat. I am Shruti Ravinder, and it's my honor to welcome you to ARYABHATA Swarna Jayanti, a celebration that is not just scientific but spiritual. Because in Bharat, science has always been sacred. Our ancestors didn't just study the stars, they saw the divinity in them. Today is April 19th, a date engraved in the Indian space history. On this very day in 1975, India launched her first satellite, Aryabhatta, into the space. And it is with that very spirit that we gather here for Aryabhatta Swarna Jayanti, a scientific festival organized by the hearts and hands of youth through the noble platform called KIYE, Kalam's Institute of Youth Excellence, a youth transforming mission. With this, I warmly welcome Mr. Gauss to tell what is space meant to India. On to Mr. Gauss.
Assalamu alaikum. Namaste everyone. Myself Shegos. I am from Sri Hindu College of Engineering and Technology. Imagine a time when a tiny satellite called Aryabhatta ventured in space in 1975, marking India's entry into the world space exploration. Fast forward to today, and ISRO has become a global space powerhouse, hitting milestones like Chandrayaan, reaching the moon and Mangalyaan, making India the first to reach Mars on its maiden attempt. ISRO continues to amaze the world. But ISRO is not just about reaching space. Its satellites empower millions, helping farmers, predicting weather, aiding disaster management, and connection remote regions. And the best part, this is the best beginning. With upcoming Gaganyaan mission aiming to send human to space and Shukriyaan sent explore venues. ISRO future promise even more thrilling discoveries. Thank you, Shukriya.
Thank you, Mr. Gauss. It was very inspiring to learn what is space for India and what is ISRO for India. To honor that moment, to reignite that fire, we bring to you this national tribute, Aryabhatta Swarna Jayanti. Sessions that span the length and breadth of Indian space and defense excellence. This is not a program, this is a change. Our aim is simple, to remind every student that you don't need a rocket in your backyard to dream big. All you need is belief. And when a Bharatiya believes, even moon is within the reach. With that, let us begin this divine journey And to help you understand the force that brought this event to life, I now invite my dear friend Deepshika to tell you more about Kalam's Institute of Youth Excellence. Jai Hind.
Good evening, everyone. I am Deepshika from Guru Nanak Institution's Technical Campus, and I'm truly honored to be a part of ARYABHATA Space Utsav, a celebration of India's rich space legacy and a platform to inspire young minds to reach beyond the stars. Today, I want to speak about something very close to my heart. Kalam's Institute of Youth Excellence. KIYE is not just an organization, it's a transformative movement founded by Mr. Naresh Indian. KIYE is a non-profit, non-political initiative born with a profound mission to spread the life message and vision of our beloved Dr. APJ Abdul Kalam through impactful training, literature, and youth engagement. I would feel proud to highlight some of the KIYE's flagship programs which are actively fulfilling Dr. Kalam's vision. Inspire India Conventions and Inspire India Space Expos. Those expos aims to make space science accessible and exciting for students through interactive exhibits, models, and presentations. And our ISRO organization had played a vital role in this expo. KIYE owes a lot to ISRO. Under the esteemed guidance of Indian Space Research Organization and Dr. G. Satish Reddy, former chairman of DRDO, KIYE has expanded its horizons, embarking on transformative initiatives such as Kalam's Yatra. As a proud beneficiary of KIYE's vision and efforts, I stand here not just as a student but as a product of an ecosystem where excellence is lived, not thought. Let us continue, ignite new dreams, celebrate our space legacy, and work together towards building a future that would make Dr. Kalam proud. Thank you, Jai Hind.
Thank you, Deepshika. With this, I request Miss Samia Mirza to tell her journey of KIYE to all of us.
Good evening, everyone. A warm welcome to all of you to Aryabhata Swaran Jayanti. I, Samia Mirza, currently pursuing family third year at Joganpalli BR Pharmacy College. I'm truly honored to stand here as a student coordinator for Kalam Institute of Youth and Excellency and a student coordinator for Aryabhata Swaran Jayanti. In the previous biggest tech event of Hyderabad, I have also been a student coordinator for Vigyan Web of 2025. And honestly speaking, the experience was something really special. Being a part of a team that worked with a dedication and a huge crowd and gathering of scientists and the students for 34,000 plus students, that gave me a confidence and a self growth and reliance that it has something really special. I really enjoyed being a part of KIYE as a student coordinator. Now coming here to Aryabhatta Swaran Jayanti, it feels same like continuing the same journey. Now, even more meaningful and more bigger, let's continue the same journey. I'm really happy to welcome you all here, and I hope that this event inspire you more, even more
Hello,
stronger, aim
आपका
us to,
faculty coordinator name जपवा जल्दी.
and help us to aim better and bigger. Now, I would like to invite the next faculty coordinator. Thank you so much. Jai Hind, Jai Bharat.
Thank you so much. Thank you so much, Samia, Miss Samia. I'm so honored to listen your journey, and I, with lot of respect, request David Salman Garu to, share his journey as a faculty coordinator of KIIE.
Yeah, very good evening, everyone. Special thanks to Mr. Naresh Indian Garu for giving me the opportunity to speak few words on this auspicious occasion. And also, I congratulate all the team members, all the students who have taken part in this and who have joined over here. And today's special guest, Dr. Prakash Chauhan Garu, Director NRSC, very thankful for you for giving your valuable time. And coming to me as a faculty coordinator, I take the opportunity and privilege because at the pandemic time, 2020, for Abdul Kalam's birthday celebrations, I was associated with Kalam's Institute of Youth Excellence as an participant. Because I'm not aware of KIYE earlier. Once after seeing all these things, the day after completing the program in the evening time, I had a call to Naresh Indian Garu after taking his mobile number at the event from one of the volunteers out there. And I talked to him and I said, sir, how can we as a faculty be a part of this KIYE? So sir has given some few inputs, and from that day onwards, I was associated with Kalam's Institute of Youth Excellence. And really, I feel as a student, not as a faculty coordinator. First, initially, I feel as a student over there because I learned a lot of things. How what the KIYE is giving the opportunity. Because I go to my earlier of my graduate days, we never got such opportunities. Because now whatever we are seeing this online, these webinar sessions and all. So more than this, the Kalam's Institute of Youth Excellence is doing very much events. Because in this, I want to highlight one point. Conducted.
Could you please unmute yourself, sir?
Yeah.
So voice.
Sorry. Yeah. As students, one event I was what I am highlighting here is students who have come over there. They are from Faridabad, Aurangabad, and far away from Telangana, not only the Telugu states. So by seeing that, I asked them, "How come you know about this, sir? Kalam's Institute, we know." So the students, because it's more for the students as well as for the faculty, also we are getting in basic knowledges to learn how the Kalam's Institute of Excellence is. Giving an opportunity, not only these things, to visit ISRO, to visit DRDO, BrahMos, all these things. And recently, what we have witnessed is the Vigyan Vaibhav, where 1 lakh plus students have visited over there. The anchors, the people who have spoken over here, these are all students are from various engineering colleges. And this is a great opportunity for each and everyone to take this forward and make utilize, because we have faculty groups many. We used to share to each and everyone, and we used to share them. They used to ask, "How come you know? What benefit you are getting?" Just one thing I used to say: benefit in terms of learning, because as a faculty, as a teacher, everyday learner, because we need to learn and we need to know the things, and we have to guide the students. That's our job. Not only getting a salaries time to time and all, and whatever subject we want to teach, that's not our motto, what we feel. And the same thing I forward to the students and to the faculty members. And not only to the faculty members, we also talk to our other college managements, principals, and head of the departments also. So I wish you all the best, and thanks for giving me this opportunity. Thanks, Naresh Indian sir, once again, giving an opportunity of this in this online session also. And recently, of course, you have completed some 100 days program also in Nizamabad surroundings, Mancherial districts and all, and Nirmal districts and all. Thanks once again, all the students and all the participants. Utilize this. Uh, that's what I can share with you as a faculty coordinator for all the faculty members of our engineering colleges. Thank you. Thanks once again.
Thank you, sir. With this warm message from you, I respectfully invite Dr. Naresh Indian sir to talk about KIYE. So could you please unmute yourself?
Thank you, Shruti. Namaste to all of you. I'm Naresh Indian, founder Kalam's Institute of Youth Excellence. We are honored and privileged to host this ARYABHATA Space Utsav. And whole India is talking about ARYABHATA. What is ARYABHATA? We know a man who contributed a zero theory, and to recognize or to in the name of him, India could able to showcase our strength. First, India indigenously developed satellite. We must thank Russia and all other supporters for the India who supported India to launch its own first satellite. Thank you so much. We also need to thank our visionary leaders of Indian Space Agency, from Professor Satish Dhawan, your and now today we are very happy to see and listen a great visionary leader from space India Space Agency, Dr. Prakash Chauhan ji. Very recently, one of our faculty, he was mentioning that Inspire India Space and Defense Expos, with the help of and blessings of Dr. Prakash Chauhan ji, we could able to inspire 1 lakh plus unreached areas. I mean, rural youth of Telangana about space and space technologies and space products. We must thank our mentor Dr. Prakash Chauhan ji for helping us to take this all the models through space on wheels program. So and we also want to thank our NRSC outreach team for the continuous help to educate all the Telangana rural children. And we all know that India so we have seen from we heard from bullock carts, we have seen Dr. Kalam pics and other eminent scientists who carries our satellites and equipment on bullock carts. And today we can see and witness we are going to have and build our own Antariksha station. And the leadership of ISRO and India space agencies and all the chairmen and all the directors and all the scientists, we must thank on the occasion of Aryabhata Space Utsav and National Satellite Technology Day. And with this, we are here to listen Dr. Prakash Chauhan ji. सर जी, आपका मदद से, आपका ब्लेसिंग से तेलंगाना में इतना बच्चों को इंस्पायर कर रहा है, ये आगे लेने का, ये बच्चों को मदद करने का आपका आशीर्वाद होना चाहिए. With this, I also want to welcome all my students and faculty coordinators, student coordinators from both the states in Telangana and Andhra Pradesh. Thank you so much. Yeah, thank you. Have a great day.
Thank you so much, sir. With this message in my heart, I would love to introduce the speaker. We thank you for staying with us on this very special day, sir. As we begin with our journey into the world of space, science, and satellite technology, it is our privilege to welcome someone who has played a key role in shaping how India views and understands her own land from above. We are truly honored to have with us today Dr. Prakash Chauhan Garu, the director of NRSC, National Remote Sensing Center, one of the most crucial arms of ISRO. Dr. Chauhan is a pioneer in the field of remote sensing, a technology that allows us to observe and interpret our planet through satellites, which watching over rivers, forests, coastlines, disaster zones, cities with incredible precision. Under his leadership, NRSC has turned satellite data into a powerful tool for planning, protecting, progressing as a nation. Whether it's managing floods, monitoring crops, or studying the environment, his work touches the lives of millions, often silently but impactfully. His contributions go beyond our borders as he continues to represent India in global scientific collaborations, sharing knowledge, exchanging data, and building bridges through science. Truly, he has shown us how space technology, when used with vision and care, can become a force for compassion, development, and resilience. It is with great joy, respect, and anticipation that we now welcome Dr. Prakash Chauhan sir to lead the session of Aryabhatta Swarna Jayanti.
Thank you very much. Good afternoon to you all. Thank you, Shruti, and good afternoon to Dr. Naresh Indian ji and all the faculty coordinators, my dear students. First of all, let me, extend my heartiest congratulations to Kalam Institute as well as to Dr. Naresh Indian ji and to all of us for celebrating this Aryabhatta, Utsav, which essentially we are basically commemorating the 50th year of the launch of first Indian artificial satellite, which was launched on this same day, April, 19th in the year 1975. And that happens to be also a Saturday, and today is also a Saturday. So it's a great coincidence that we are celebrating the wonderful journey of Indian space program. So I am going to talk to you about 30 minutes or so, very quickly, to talk about 50 years development. 30 minutes is a very small time. But what I will do, I will try to give you some highlights of this great journey of India's space activity of last 5 decades or so. So I say that it is Aryabhatta to Aditya, L1, our latest satellite, which was essentially study the sun, and already giving a lot of wonderful data about the sun and the solar processes. So, our start was very small, like what we call as the baby steps. In 1960s, when Professor Vikram Sarabhai, he conceived India's space program. After this, dawn of space age, which basically started in 1957 with the, launch of Sputnik satellite, the first artificially created satellite by humans. We also started, dwelling into space activity. And at that time, a lot of people laughed that why a country, a poor country, those days we were not as, economically good as today we are, that why we need a space program, a costly affairs. Then Dr. Sarabhai, he told that India's space program will be for the societal development and for the benefit of the common man, not to fight, wars with USA or USSR, or, showcase, the muscle power. So now 50 years down the line, if we see today, we are using space technology in all spheres of life. I will talk about it, subsequently. Then, of course, we established in Thumba our, sounding rocket launching station, which was launched on 23rd November 1963, in a fisherman village very close to Trivandrum. Now that place has basically become a museum. And if you go to Vikram Sarabhai Space Center, you can visit that particular, church from where the India space program started. So virtually from zero infrastructure, somebody talked about, carrying parts of satellites, rockets on bullock carts, or even bicycles. Many of those pictures you must have seen. So with that, from that day, so determination, commitment, and very importantly, leadership. Today we have the self-reliant space infrastructure, which basically is meeting the needs of the national development through innovations in science and technology. And India is one among the four first space-faring nations of this world. Today, our footprint is not only there on the Earth. Our footprint is all the way up to, Mars, and we are also there, studying Moon from Lagrangian point position. So that is what is the, significance of this journey, which essentially started subsequently on 19th April 1995 by the launch of this, first satellite, which was made by Indian scientists in Bangalore. It has all started, with a signing of an MOU with Professor Satish Dhawan. Here you can see this picture, and Professor U.R. Rao. He was the first project director of ARYABHATA satellite mission. He is standing here in this photograph, where we are signing an agreement with the Russians to launch this, ARYABHATA satellite. And the ARYABHATA satellite was basically supposed to be a less than 100 kg satellite, but basically by the time it got conceived and then 26 face hexagonal shape it had, it was supposed to do X-ray astronomy, aeronomy, and solar physics kind of experiments. So this became around 380 kg satellite, and it was launched, on this day, same day today, April, 1975, from Kapustin, Cosmodrome. This is a place in Russia today, and then a rocket called Cosmos 3M rocket, on which this satellite was carried, and this was named after the 5th century Indian astronomer and mathematician Aryabhatta, who has done, splendid work in the field of mathematics. And then the purpose was, as I told you, to study X-ray astronomy, aeronomy, and the solar physics. Some of the people, those who are, aware about, some of the cosmic radiations like X-ray radiation, etc., they can appreciate that. But we'll not go into details of this. And the design, as I told you, 26-side polygon, and around 360 kg weight with 1.4 meter diameter. And it has, solar panels, which was providing 46 watts of energy, from all its hexagonal faces. And then it was launched into an orbit where it has an apogee of 619 kilometer, perigee of 563 kilometer. The satellite was supposed to orbit a couple of, lot of orbits, but of course, after 4 days, we lost communication from the satellite itself. And then, but it gave us very vital data in terms of, developing first of its kind of satellites, telemetry, connecting to the satellite systems, connecting to the ground-based systems, and to commemorate, this wonderful achievement of Indian scientists, the Russian, that time what we used to call USSR and India jointly, also issued, a lot of postal tickets, this is one Russian ticket. Similarly, Indian postal tickets were also issued. And then many of you now, young boys and girls, must have not seen this 2 rupee note. But when we were children of your age, this was the most popular note, because in 2 rupees you can buy a lot of things those days. So to commemorate the success of Aryabhatta, the picture of Aryabhatta satellite was also printed by Reserve Bank of India. That was the significance and a milestone moment, which happened 50 years back. And afterwards, we have not looked back. And today, if you see ISRO's infrastructure as well as our total space ecosystem in the country, this map shows you various units and various entities, almost more than 20 units and entities of ISRO doing various kind of space activities which are there throughout the country. In Andhra Pradesh, we have our launch pad. In Telangana, we have National Remote Sensing Center. In Bangalore, we have Space, ISRO Satellite Center. Then, of course, ISTRAC for telemetry. In Hassan also, we are basically monitoring our geostationary satellites. In Trivandrum, we are developing, the rocket systems. In Mahendragiri, Tamil Nadu, we are having, IPRC, where we do a lot of tests for our liquid propulsion engines. And then similarly at Ahmedabad, we develop sensors. And in Lucknow, we have a telemetry center. In Bhopal, we have a telemetry center. In Dehradun, we have Indian Institute of Remote Sensing. Similarly, in Meghalaya, we have Northeast Space Application Center. So throughout the country, a lot of space activities in ISRO, is happening along with a big ecosystem around ISRO has developed where 450 plus industries are supporting us, where 450 plus medium and small scale enterprises, 50 large companies, last 2 to 3 years, around 100 startup companies led by very young people have come up thanks to the space policy which has been unveiled by Government of India. Lot of interaction with the universities, IITs, NITs, engineering colleges, and other colleges where we are doing large amount of sponsored research on various space-related problems, and of course many other institutions and ministries are collaborating for entire space ecosystem in this country. From that single tiny small satellite which was launched in 50 years back, today we have grown to this extent. If you talk, our overall program dimensions, so essentially it's a people-centric and application-driven program. Unlike Russia, unlike China, unlike USA, where the space program originated in military domains, in India, basically the entire program started in the civilian domain to help common man of this people of this country. So we have, full end-to-end capability for launching any kind of class of satellite by our operational launch vehicles like PSLV, GSLV, LVM Mark III. We have developed a new small satellite launch vehicle, and we are now going to develop the next generation of, the launch vehicles called NGLV, etc. Then we can basically make all kind of satellites in the country today. The communication satellites, which provides you direct to home services, many other satellite communication advantages when you are in deep ocean. For our Navy, entire communication needs are done by the communication satellites. Then navigation, your position and navigation and timing service, like what you call as GPS service, navigation service which you use in your mobile phone. We have our own constellation called Navi. Then, of course, space science related activities, like Chandrayaan 1, 2, 3. Now we are building Chandrayaan 4, Mars Orbiter mission, Aditya L1 mission, ExpoSat mission. These are all missions which are basically for exploring the solar system and beyond. And then this data, which comes from many of these satellites, is used for various applications for disaster management, resource mapping, societal communication, and many other activities. We are also adding a new dimension to India's space program called Human Space Program. Somebody talked about Gaganyaan, program. So The objective is to send Indian-born boys and girls and what we call Gagannauts, into space with indigenously developed, our own rocket systems. So work is happening on a very advanced stage. 3 flights are supposed to be there, 2 unmanned and one finally a manned flight. We have already selected, 4 astronauts or Gagannauts have been identified. Last year, our Honorable Prime Minister Narendra Modi ji has given wings to these 4 astronauts, those who are coming from Indian Air Force. And this year, probably you may see the flight of the first unmanned, Gaganyaan program, which is the first of this series of three, flights which are supposed to happen. And of course, we also help a lot of, capacity building programs, outreach programs like this one, which we are doing today, to tell to our young people, to inspire them and to educate, train, a lot of people, because space is a very complex field. It's a multidisciplinary field. And of course, we also develop large amount of facilities, not only for ISRO, but nowadays for use of industry also, because space technology is a very advanced technology and it needs a lot of money also. So we can develop centralized facilities which can be utilized by all players of this ecosystem today. So this is in nutshell, the overall space program which we are having today. We have launched more than 100 rockets. In January, our 100th rocket launch has happened from Sriharikota. That was also a very momentous occasion when we made a century, of rocket launches from our spaceport from Sriharikota, where all kind of rockets, the initial ones like SLV, then ASLV, then PSLV, which is basically a workhorse now, then GSLV, Mark II, Mark III, and then a small satellite launch vehicle. All class of satellite launchers are launched from our Sriharikota. We have developed more than 130, spacecrafts we have developed indigenously from the ARYABHATA days. We have launched 431 foreign satellites, not only for Indian, our own use, but we are also, doing commercial space activity for 34 countries. 431 satellites has been launched by India, and in one particular mission, in one stretch itself, we have launched 100 satellites, and they are still orbiting and providing a lot of valuable data sets. Similarly, a lot of experiments are also being done for re-entry, reusable, space transportation, student satellites. And recently, you must have also heard about a very interesting experiment called SpadeX, where 2 satellites, traveling with a velocity of 28,000 kilometers per hour, they were basically brought close to each other and they did docking, and then they did undocking also. So this type of experiments are very much required when we develop our own space station, because space station cannot be built in one go. We have to send a lot of modules, and all these modules in space has to join to make the full, space station. And then the crew also has to go from here, and then it has to do docking and undocking. So to master docking and undocking technology, SpadeX mission was successfully demonstrated. Apart from that, as I told you, we also want to, enhance our knowledge about our own solar system. We want to know that what is happening in our neighborhood, what is happening on moon. So we have launched in 2008 Chandrayaan mission, then Mangalyaan mission in 2013. Then of course Astrosat. It is our multi-wavelength observatory to know about the stars in our galaxy. Then, of course, Chandrayaan-2, where we wanted to soft land onto the moon surface, where an orbiter and a lander was there. Orbiter is still working, but lander, as you know, that it could not land and it crashed. But we learned a lot of things, and then we came back after 4 years. And 2023, you all have seen the first successful, soft landing on the south pole of the moon. And then, of course, afterwards, we have launched, a solar observatory at Lagrangian point 1, Aditya L1, and still providing a lot of data about our own God in the solar system is sun. If sun is not there, or if sun becomes angry, all of us life, get disturbed. So we need to know about sun. So this Aditya L1 is a mission which is providing large amount of data from sun and solar processes like coronal mass ejections, etc. So these are the operational vehicles. I will not go into details of this. Many of you know about it. Then, of course, currently we are operating 57, satellites in different orbits. We have 26 Earth observation satellites in civilian as well as in strategic. When we say strategic, that means it is meant for doing some work for our armed forces, for generating some knowledge about our borders, our neighborhood, etc. And then we have, this communication satellites, 18 communication satellites are there, which is providing, very valuable data for direct to home. All these television programs which you see through your DTH in your home, all the television broadcast, IPL matches, any cricket match, football match coming from any part of the world, it all comes through these communication satellites to your home. A lot of news and print media people, they use satellite communication. If they are reporting from remote areas, a live telecast coming from, let us say, in remote part of Assam, it basically is done through a OB van where a satellite dish is mounted on a car or a mobile van, and then the program is beamed to a satellite, and then it is broadcasted in all part of the country. Then, of course, nowadays, the communication satellites are also providing internet. You all must have heard about Starlink. Starlink is going to provide you internet from satellites. So similarly, we have this high throughput 25 Gbps bandwidth satellites from India also providing internet services in remote areas, especially in Himalayas, in Andaman Nicobar, in Antarctica also. A lot of our colleagues lives in Antarctica. NRSC scientists are also working in Antarctica. So if they have to connect to their home, if they have to talk to their parents and family members, they use this satellite communication. Navigation is very important, as I told you. Even if your pizza, if you want to get to your home, pizza cannot come without navigation satellite, because that fellow has to trace your home. A live location. Live location is coming from what? It is coming from satellites, like a GPS satellite or a Navik satellite. So we have put 8 satellites in a regional constellations. Then, of course, as I told you, space exploration program. So all these satellites are launched for some purpose. They are not just launched just like that, because each satellite costs around 200 to 300 crores. The launching cost is around 100 crores to 150 crores, or even sometimes 200 crores. So these are all very expensive items. So each satellite works for 5 to 7 years. Or even up to communication satellites work for tens of years, and they provide a lot of services. So like communication infrastructure, data connectivity, broadcasting, education, monitoring natural resources like water, agriculture, forest, weather service. I will show some example of weather also. Then, of course, how is the health of coral reefs, mangroves, forest. That environmental aspects are also provided by these satellites. Then strategic services. I think there was some problem in between. I got disconnected. Can you hear me now?
Yes, sir. It's
Yes, sir.
clear, sir.
Yes, sir.
Are you able to see my slides? Not now.
Not now.
Just a minute.
It's we couldn't see.
Yeah, just I will put it again. Can you see the slide now?
Yes, sir.
Yeah. So these are all the kind of applications of this satellite data. Now, this is how a satellite looks like, you know. This is a satellite which basically a satellite which provides very high resolution data. It can see around 20 centimeter objects on ground. This is called Cartosat series of satellite, and it will carry, you know, this type of, you know, telescope. So this is a 1.2 meter mirror telescope which is flown to this particular. This is how a sensor look, and this is how a satellite look. This basically will be an SUV car size of a satellite, and then it will be lifted by, you know, those rockets. And when this satellite goes into orbit, you know, this type of data it starts giving. You can see our old parliament here in New Delhi. You can see the new parliament. You can even see Rashtrapati Bhavan. Even some cars are also seen, new buildings, even individual tree canopies you can count. In these Mughal gardens, how many trees are there? You can count using this satellite data. So this is the kind of, you know, details today we can get from these satellite images. Which are captured by that satellite which I showed you. So not only these 2D images, we can also generate topographic information, three-dimensional information. So this is, I'm taking you to Himalaya. Now you can fly over Himalaya using this 3D data. We are going to fly over Gangotri Glacier. So I am going to show you how a river gets water from a glacier. So this is river, you know, Bhagirathi, and then this is Gangotri Glacier. So now you are able to fly on a glacier. Glacier is basically a river of ice. It is stored over 10,000s of years, and when it trickles, you know, it melts, then the water is produced. And in rivers like Ganga, in rivers like Brahmaputra, all Himalayan rivers, you know, they get water by melting of the snow and ice from these glaciers. So you can do a digital mapping or create a 3D digital twins of Earth systems using this type of satellite data. Apart from that, we can produce maps of agriculture. How many of you know that, you know, what kind of crops are produced in Telangana? You know, Telangana produces a lot of rice. From which district your rice is coming? All that maps we can create, you know. So this is the help with the help of satellite data, we can also know that how much water is available in our reservoirs. You know, during the summer, you know, the water scarcity is there in most of the cities. So Hyderabad gets a lot of water from this Usman Sagar and other dams. How much water is available? How much water is remaining? All that information we provide to the, you know, the administrators which are administering water using the satellite based observation. Similarly, you know, in areas like deserts, groundwater is a big problem. So using satellite data, we can identify structures where the groundwater will percolate, you know, when the rain happens. And then by doing some other methods, geophysical techniques, you know, we can pinpoint that if you drill at this location, you are sure to get water. So this is another beautiful example where a lot of village people in Rajasthan, we have helped them in getting water. Here in Gulbarga, which is a very dry place, you know, very close to Hyderabad, we have helped a lot of schools and colleges to get, you know, very good quality groundwater with the help of satellite technology. Then, of course, you know, we are all facing issues related to climate change. And the why climate change is happening? Because we are burning a lot of fossil fuels like, you know, diesel, petrol, gasoline, coal. So this is adding to the carbon dioxide in the atmosphere. You know, before industrial age started, the carbon dioxide concentration in Earth's atmosphere was only 300 parts per million. Today, in my Shadnagar campus in Hyderabad, we are making measurements of carbon dioxide every day. Today, ambient carbon dioxide amount is 425 parts per million. It has increased by 100 parts per million in last 50 years. And carbon dioxide, friends, you know, it is a greenhouse gas. So if its concentration will increase, you know, lot of, you know, the radiation which goes out of Earth cannot go. It traps that radiation, and which leads to the warming. Already in India, we have reached 1.3 degrees centigrade warming from the before the industrial age started, and we all want to contain it before, you know, below 1.5 degree. So 1.5 degree is not going to happen. Now we are happy that by 2100, if we can contain below 2 degrees Celsius. So if we want to do, we have to go away from this hydrocarbon based economy. We have to go for green and clean fuels. So for that, solar energy everywhere today, India is the leader in, transforming or adopting solar energy. And in many areas, solar hubs are coming up, solar parks are coming up. We have established 57 solar parks. So using this satellite data, we can also map which area of India gets a lot of solar energy. Throughout the year, in Gujarat, in Maharashtra, in Telangana, lot of sun energy. This blue color shows you where throughout the year sun is available. 300 plus days, good amount of solar radiation is available. But if you go to northeast, which remains cloudy, North India, there is not much of sun. In Kerala, there is a lot of clouds are there because a lot of rain happens. So in these areas, solar production basically is not that good. But in states like Rajasthan, Gujarat, Telangana, Maharashtra, Andhra Pradesh, Karnataka, solar energy is very successful. So using this type of technology, we are providing what we call as a solar calculator. Today, using this, you can download this, you can stand on your rooftop. How much solar energy throughout the year you can generate, this calculator will tell you based on satellite data. And then you can plan to put a solar power installation, which is also being subsidized by Government of India. Generate your own energy and you can become free. Generate your free energy because sun is there, especially in Telangana, almost more than 300 days. So this also, ISRO is helping in a big way in finding out hotspots of renewable energy. This is one particular image, from satellites, you can see this big solar park. This is a solar park in Rajasthan. Almost, 220 kilometer by 20 kilometer area is covered by this solar park. And this is how this solar park looks like from space. And today we can monitor that, how many such solar parks are there in India. Similarly, disasters like flood, early warning in floods, cyclone, many such places, space technology is being used. We are also helping our fishermen. We are providing what we call as potential fish zone information to 9 lakh fishermen across all maritime states. And then they are going and, morning, suppose if you are a fisherman, the ocean is so big, where you will go and fish? So who will tell you? So from space, we are telling you go to this location because we are monitoring chlorophyll, which is a food for fish. We are monitoring temperature of the sea surface. We are monitoring currents. We are monitoring wind. Based on this multi-parameter, we come up with a solution called potential fishing zone. And the fisherman goes to those places. They good profitable fishing. They save oil also. Their hunt time is also reduced. They come back early and their profitability is also increasing. And along with that, we are also providing a messaging service to them. If they are lost in the sea, and since their mobile phone after 20 kilometers doesn't work, they cannot message. So using this Navik, constellation, they can do a small messaging service that I am in trouble. Please save me. So our Coast Guard vessel goes there and then trace them and then do rescue. Sometimes fishermen goes to Pakistan border or Sri Lanka border. So in that case also they face a lot of problems. They can get caught by these people. And then this messaging service tells them if they're crossing the border, please don't cross, you are going to get caught. So this type of help is also coming from space. Similarly, we have 2 satellites in 36,000 kilometer orbit called INSET 3D-R and INSET 3DS. Every 15 minutes, they provide, this weather images. And using these weather images, adverse weathers like cyclone, typhoon, all those things we can monitor. And today our forecast ability for cyclone is better than 5 days. 5 days in advance, we are able to tell our people that a cyclone is going to strike Andhra or going to strike Orissa or West Bengal. Please be careful. You go away from the coastal areas, go to shelter houses, and millions of lives are being saved by this type of satellite systems. Similarly, we have done this lot of experiment like Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, all of you are aware. I will show you some images from Chandrayaan 1. You see, this is how a moon looks like in night if you see. But Have you ever wondered what are these small, spots on the moon? Moon has a lot of impact craters because there is no atmosphere. So all these meteorites, they hit moon surface. So this is one of the crater. This photo is one of the crater. It's called Tycho crater. This crater is so big, if you travel from one corner to the another corner, it is 84-kilometer long crater. And when such craters forms on moon, they also have a rebound of the moon surface. So in such craters, there is a central hill gets produced. It is called complex craters. So there is a hill also in the center of this crater. This particular crater you can see from your naked eye also. You can go to your rooftop, and when full moon day is there, in the south part of moon, this particular spot is there, which has long rays also. And this is how the satellite image, in a satellite image, this crater looks like. And the central portion, if I zoom further, this is how a hill looks like on moon. So it is very much similar to the hills what you have in Hyderabad. Lot of debris is coming out of this, and then there are cracks on the moon surface, floor cracks. So they have such a technology that even a small minute stone today can map onto the moon surface also. This is the technology India has developed. This is another big crater. Crater ke upar crater ke andar crater. So there are so many craters. These are called multi-ring basin craters. So you have big craters, then over that there is another crater, there are multiple craters. So all these craters tells you the geological history of moon, how it has evolved, how many times it has beaten by the asteroids, or meteorites. So this type of data is also very wonderful data which has come from satellites. This is how is a beautiful image of Mars from Mars orbiter mission. The Mars has pole on North Pole and South Pole, ice is there. Like on Earth, there is ice. So similarly, on Mars also ice caps are there. Mars has the largest volcanoes of the solar system. So this particular one is called Olympus Moon. What is the highest hill on Earth? Mount Everest. It has a height of around 8 kilometers or so. But on on Mars, the Olympus Moon has height of around 25 kilometers. So it's a huge mountain. In fact, one of the largest mountain in solar system is on Mars, and it is called Olympus Moon. This is the photograph of this particular, mountain, which our own Mars, orbiter mission has captured beautifully. Okay, and there are a lot of dust storms also happens, like here dust activity happens. Similarly on Mars also a lot of dust storm happens. I will just tell you a story of this Chandrayaan 3 landing, how beautifully it landed. And then how do we know that it has landed? Many people will say, give us the proof that you have landed. Simply by saying it doesn't help. So, this is the image. We have a camera on Chandrayaan 2 orbiter which can give you 20 centimeter image of moon. So this was on August 23rd at 2 p.m. IST, and then night after landing we did again imaging of this area, and you see that suddenly there is some change in this image, and this change was nothing but it is our orbiter which has come and then landed there, and this became the proof. Everybody in the world, when we released this image, they told, yes, you have landed. Otherwise, they were telling that you are making stories. So this is the most important proof which came that India's made Vikram lander landed onto the moon surface, and this is the shadow of that lander, which you can see, this black shadow. And then our own, that rover came out from this ramp and then it took the photograph of the lander. So this is the photo taken by our rover of the lander, and this also was a very historical image, and this is how, the lander, the rover came out from the lander. This is the video. Okay, how a rover coming out onto the moon surface, and it has India's flag also. You can see over here. And then wheels, the Ashok Chakra, that 4 lions, they were imprinted on the wheels of this particular rover. So what we say that the rover has imprinted 4 lions on the surface of moon. And of course, Indian flag is already there on the moon surface. You can see this again. And this also made a century on the moon surface. It traveled around 100 kilometers onto the moon surface and then collected a lot of important data about the moon soil. So, these are all the excitement of recent journey after that ARYABHATA. going all the way up to moon and landing on moon and putting India's flag on moon surface. And of course, now we are going to launch Chandrayaan 4, the lunar sample return. This Chandrayaan 4, we will land, not only land, we will collect the moon rocks, and then that moon rock will be brought back to the Earth surface. It's easy to say that we will bring back, but a lot of technological challenges. You know what is the distance of moon from Earth? It is 384,000 kilometers. So bringing something back from moon is very, very challenging, and that's what we are going to attempt in our Chandrayaan 4 mission. And of course, to end, I will show this Aditya L1, mission. This was supposed to study sun, and there is a point called L1. If you put a satellite in this L1, then continuously you can look towards sun. And these are first kind of images of the sun which has been captured by this mission. There are something called black spots or dark spots on the sun. So it can measure all these dark spots. It can measure coronal mass ejections. It can measure, the kind of plasma which is generated by the ejection of this coronal mass activities. And then when it comes to Earth surface, modeling can be done. What impact it will have on the satellites, that can be done. So a lot of scientific knowledge about the moon, about our own sun, is being acquired by this Aditya mission. Gaganyaan, as I told you, there will be 2 unmanned flights, and one will be the manned flight. This year itself, we will have, a manned flight, and then we are doing a lot of international collaboration with French, with Russia, as well as with America, in terms of developing various technologies, so that we can not only, it's easy to send a person on any rocket. I can put you on any rocket, but you will not come back if it is not, in a proper environment, because in space there is no air to breathe. The pressure is very high, very low. So you can implode if you are not put in a proper environment. So all those kind of, environmental capsules are being developed, which is called actually, the crew modules and then service modules. And then, a lot of testing, simulations, etc. are happening in ISRO, so that we can not only send a human into space, we can successfully bring it back. And then there is a process called re-entry. When you re-enter into the atmosphere, the temperature of the body, it goes more than 4,000 Kelvin or so. So the module has to sustain this heat, otherwise it will blast off. Then you cannot bring the astronaut successfully. So recently you must have seen Sunita Williams came back, on a SpaceX module. So similarly, with this type of technology we are now working. We are almost 60, 75 years behind Americans. In 1969 itself, they have put, astronauts onto the moon surface. So this is where, we lag actually. This is a newly developing area, but I think rapid work is happening in India. We also do a lot of collaboration with international countries. NISAR is a mission, NASA ISRO synthetic aperture radar. It will be launched in the month of June. Then with France, with Japan, with many other countries, we are working together. And of course, there are a lot of private companies are developing today. We have a lot of, space companies here in Hyderabad. Dhruva is there. Skyroot launch vehicle systems are there, and then many companies which are doing space applications. These are some of the Indian companies which are doing fantastically well. They are now basically, leaders in the space activities as far as private sector participation in space is concerned. Recently, this list has been released. So it's not that ISRO only is involved. Lot of other people are doing space activity in the country today, and a lot of young people are joining the space excitement after that 50 years back, that history which was made. So to conclude, as I say, that as India steers towards becoming a developed nation by 2047, the space technology will play a very important role. We have, a lot of missions like Chandrayaan 4 sample mission, Bharati Antariksh Station, Gaganyaan. Then by 47, Indian has to land onto the moon surface. We have to develop advanced systems and innovative technologies to do so. Then arrangements we have made within, different institutions in India for, use of space technology. Then entrepreneurship, business development, job creation, social welfare. All these aspects are basically getting touched by the use of space technology. So space is not only technology, it touches everyone's life in this country, but we have to do a lot of work if we have to reach, a large population of India, and in that the youth, so y'all, you young people, you have to take a leadership role in years to come. In next 25 years belongs to all of you. You have to contribute whatever field you are there. Either you are an engineer, or you are a lawyer, or you are a painter or singer. Do your best so that we can make our country great country in next 25 years, because India has age dividend. All of you are very young. India is a young country, and for next 25 years, with your support, and we all look forward towards our next generation for contributing in an excellent way for the growth of this wonderful nation. Thank you very much for listening to me. Now we can ask if you have some questions. I will be happy to answer.
Thank you so much, sir. As now that we have launched into a world of inspiration and insight, it's time to bring your curiosity into the orbit. If you have any questions for our esteemed speaker, anything about India's space missions, remote sensing, or what it's like to work with ISRO, drop them right in the YouTube live or in our chat, or raise your hands. We'll be taking you and you'll be asked. Drakshi Mishra, could you please unmute yourself and ask your question?
Good evening, sir. It's my privilege to ask you a question. Sir, my question is that as we are seeing that there are more and more numbers of satellites orbiting around the Earth. So I wanted to know here that, sir, if as there are large number of satellites, so is there like we are taking any concern to protect the atmosphere, like it can affect the atmosphere? Also, like there will be a chances of collision with other satellites, because there are some more countries satellites will be also orbiting the Earth orbits. So wanted to know like what concerns are there, and how we are ensuring that the satellites must not collide with other satellites.
You are absolutely right. The space around Earth is becoming very crowded. There are, large number of objects, because now space journey started in 1957. So already so many satellites, dead satellites, which are not functional, they're all there orbiting in those, orbits, in different orbits. So space is a very congested place, but it's not that congested as of now. But already this is a big talk of discussion, and ISRO has taken lead in this, that we are saying that all our missions are going to be debris-free missions. So what we will do, suppose any satellite stops working, we will, lower the satellite's orbit slowly, and then it can re-enter into the orbit of space. Then most of the portion of satellite will get burned out, and then it can land safely in some ocean. So that is one strategy. Then similarly, the other countries of the world are also talking about space debris management. They are talking of collector satellites. But one satellite can go and then scoop, lot of debris and then bring it back or do re-entry so that it can burn out. So like that, many strategies are being planned. We are also working on a mission called Netra mission, where essentially you have to track all this debris. Today, NASA keeps eye on all these debris and space collision. In fact, whenever a rocket launch happens from Indians, Sriharikota, we have to very carefully, see that any kind of debris is not flying. Recent few satellites, we have to delay by few minutes so that, something was passing over, that the collision can be avoided. So all these things are being monitored today, and there are strategies being worked out among various nations, to remove this debris so that, space remains a sustainable place. Sustainable place means for next generations also will be able to take advantage of space as a vantage point. It's not that we people have done this thing and then we have created all this kachra. And then, after 20 years, you simply cannot use these orbits. So already serious discussions are happening under United Nations ambit, and a lot of programs and guidelines are being issued. Okay?
Yes, sir.
Thank you, sir.
Mr. Anirudh Shetty, you please ask your question.
Yes, sir. Good evening, sir.
Yeah, Anirudh. Yeah, good evening.
Sir, my question is that since satellites have taken, since satellites can take high resolution images of Earth, is there a risk of that they might see or reveal the secret defense activities of the country? And how do nations protect such sensitive information from being exposed?
So there are satellites which are doing this only. See, you remember, you must have heard a story when India was supposed to do the nuclear, blasts. Okay, we were carefully planning. We were knowing when the American spy satellites comes, and then entire activity was to be done when those satellites were not available, so that Americans could never know that what we were doing. So like that, each country is also trying to get information about other strategic activities. So this is not only a threat, this already is happening. And today, using this high resolution satellite data, lot of things are exposed. So we have to take protective measures. We have to have strategies of camouflaging materials which look similar to natural materials like trees, etc. So these techniques are called camouflage techniques. There are techniques also where you can block the signals of satellites, by putting counter frequencies, similar frequencies, by spoofing those frequencies of the other satellite. You can also reduce the penetration of their imaging capabilities. So many such measures are available, and then you can put your critical assets underground so that they are not visible. So, or you can put them under bunkers or hangars so that the enemies don't know that what are your critical assets. And so these type of counter strategies are also available with people, those who deal in these areas. Okay, but definitely today nothing is hidden in the world. If you are doing anything in open, even if you are taking bath in your bathtub, which is there on the roof of your apartment, you can be seen. That is the level of level of information which can be revealed by satellites. Okay.
Rishi Vardhan, Mr. Rishi Vardhan.
Good evening, sir.
Good evening.
Sir, I'm curious to know what specific skills or academic areas should students like us focus on if we hope to contribute to such prestigious organizations like ISRO and NRSC in the future.
Okay, so if you want to become or if you want to join ISRO, you have to, there are 3-4 ways you can join ISRO. You can join as a scientist, engineer, you can do BTech degree, then after BTech, you can write our national level, BTech in any branch, computer science, mechanical, avionics, civil engineering, mechanical engineering. These are the most popular branches. Then there is a centralized exam every year. You have to qualify, that there is an interview. If you clear that, you can become a scientist or an engineer in ISRO at entry level. Then if you are a science graduate, you have to do masters or PhD in certain specific areas. Then there are also recruitment opportunities. If you are a 12th class student, you can think of joining our institute called Indian Institute of Space Science and Technology in Trivandrum. And if you pass through with some good grades from IST, you can directly join as a scientist engineer. The job is guaranteed, but you have to clear JEE Advanced exam for that. And then there is an administrative scheme also. If you are willing to join ISRO, but not in technical arms, in administration, because a lot of people are there in finance and budget management, in HR, and many other areas. There are also opportunities of joining ISRO which are advertised. But apart from ISRO, a lot of private companies are also recruiting people with these skill sets. So those that particular domain is also enhancing. So you need to have engineering degrees or science degrees for getting into the space sector. Okay.
Okay, sir. Thank you, sir.
Mr. Edulakanti Anil, could you ask your question?
Good evening, sir. It's really great to be a part of celebrating 15 years of ARYABHATA, sir. And my question is, what advice would you give to students who want to work in space research?
Okay, so space research is a very wide subject, it involves, lot of domain. You can be an astronomer, you can be a astrophysicist, you can look towards, utilizing or a planetary scientist, or you can be an earth scientist in various domains, or you can be an engineer who develops technologies. So it depends on your interest. Suppose if you want to pursue, let's say, astrophysics, then you need to learn a lot of skills about various observational methods, physics, knowledge of physics and mathematics, modeling is required. Then observational platforms, you have to analyze a lot of data. So data analysis capabilities, data processing capabilities, computer programming, all these kind of skill sets should be there. But since the space is so diverse, there are, as I told you, every field has some kind of a role. A computer scientist, a chemistry person, a physics person. Even we have agriculture specialists in ISRO also. We have biology, botany people also are there in ISRO. So it depends on your interest. For each interest, we have something to offer, but the avenues may be limited for certain categories, and for certain categories there may be more scope also. Okay, so if any specific area you want to have some interest, you can contact me. I will guide you. Okay.
Sure, sir. Thank you, sir.
Miss Samya, would you like to ask your question?
Good evening, sir. I'm Samya.
Yeah.
I would
Good
like
evening,
to ask, what is your specific about the inventions or the specific things you are excited about the space sector? So, what are the inventions or technology which you are more excited about in space sector?
Actually, everything is exciting in space, actually. So, you see, we found, water molecules onto the moon surface for the first time. When people used to think that there is nothing, no water is there on moon. Indian missions like Chandrayaan 1 and Chandrayaan 2, I was personally also involved. We found those water molecules. It was a big discovery. In fact, first of its kind in the world. Then, of course, we went to Mars. We could map the surface of Mars. We saw a lot of new things on Mars. We found a lot of ice-covered areas. We understood about the Martian atmosphere. Then, of course, coming back to a lot of new satellites which we launched recently, SpaceX. Joining two fast moving satellites together with the precision in space, remotely sitting here on Earth is really exciting. You just imagine. Then landing, of course, onto the moon surface is the greatest excitement. It was the event which was most watched on YouTube, not only in India, world over. So what an excitement it was. So there are a lot of exciting stories. I can keep on talking for the whole day. So each and every activity is exciting, because many times most of these activities we are doing for the first time. Whatever we do for the first time, you all as a young boy and girl, that it really excites you. Afterwards, it becomes routine. So space provides you that that kind of opportunity that you can learn new. And now on our human space program, we are sending probes even to see that a seed sprouts in space. How plants grows in space, such a simple thing. Every day we see plants growing here on Earth, but whether in microgravity condition, how plants will behave, how animals will behave, how fungus is going to behave. All those kind of exciting biological experiments are also being planned.
So, what are the upcoming missions that we doesn't know? What is going on right now? What are the new upcoming missions that we people doesn't know? Can you speak something if it is?
Everything is available on internet if you Google. So we are going to have this Chandrayaan 4, the most exciting mission, where we are planning to bring the moon rock back to Earth. It will be a real huge excitement. A piece of moon is going to come on Earth. Imagine what will happen. It will be such a wonderful thing to see a moon rock, in your hand or in your laboratory. So that is the mission which we are planning, Chandrayaan 4. Then with Japan, Japanese space agency, which is known as JAXA, We are planning to land again on the south pole of the moon. It's called Chandrayaan 5 or LUPEX mission, and we will explore, in great detail the south polar region with the help of a lander and a rover. So that rover will look for the signature of water, ice onto the moon surface. So in future, people are planning, to have colonies on the moon. So there is a program called Artemis program by NASA where now they want to put astronauts onto the moon surface back again. So now once people are living on moon, they will need a lot of water. They will need oxygen. So how much you can carry from here? So you have to find some resources there. And if you find them, then at least few people can live on moon also. And then they can see from moon a lot of other things as a vantage point. That is Chandrayaan 5 program. Then we are also going to send a mission to study Venus planet. Then of course, Bharati Antariksh Station is going to come up. Then, of course, Gaganyaan follow-up program is going to come up. And by 2047, we want to put an Indian boy or girl onto the surface of moon. Okay. So, so some of you can see that happening. So these are all real exciting things which are going to be there for next 10 to 15 years. Okay.
Sure, sir. Thank you so much, sir.
So there are few shout out questions from YouTube Live, sir. The first question
Okay.
is, sir, this is Amit Varma. My question is that did any other country send satellite towards sun before our Aditya? If so, what are all output by this research?
Of course, there were a lot of other satellites were there. Americans have already sent. There is a observatory called Soho Observatory. So, and then there are a couple of missions by other countries also to study sun. Or there is a branch of science called heliophysics. Physics of the sun. So these are all making continuous observations of the solar disk, and they keep an eye on solar processes. As I told you, the sunspot activity or the plasma bursts, which happens when sun get angry. It throws a lot of plasma out of the sun's body, and when this plasma, which is basically a material state, it has a lot of charged particles. It travels in the solar system in all directions, and sometime it reaches Earth, the outer surface of Earth also. So there are a lot of satellites which orbit. So this charged particles, they can create problems to your electronics of your satellite, and sometimes satellites can stop working. So we have to protect. They can cause also geomagnetic storms in the Earth's ionosphere. So these are all kind of effects which are produced by this type of coronal mass ejection activities of the sun. So there are regular observations which are being done by, especially by NASA. They have a full-fledged developed program, but ISRO has also joined it. The advantage is that we are now studying sun in different frequencies of electromagnetic spectrum. So some of the unknown aspects can be studied in ultraviolet range of electromagnetic spectrum, and then some studies related to ionization of this plasma, how much charged particles are, their density is there, those kind of computations, this our Aditya L1 is providing in a much better way compared to what is available today from international missions. Okay.
Yes, sir. And the second question, sir. Sir, how satellite concept evolved, that that is how this concept came into the existence for the first time.
Oh, really? Yeah, that's a great question. See, what is our natural satellite? See, we have a natural satellite which is moon, okay, which goes around the Earth's surface with certain periodicity, okay, that we are aware. So now, early astronomers, those who were doing astronomy, they started also observing satellites of other planets also. Mars also has two satellites, Deimos and Phobos. Similarly, Venus have around 56 satellites. So the idea of, making, if you want to know about Earth, if you rise, let's say, some of you must have gone by aircrafts. So suppose you are at the surface, but if you go to the top of your roof, you can see more. If you go onto top of a 30-story building, you can see more area. So if you go to an aircraft, you can see much more area. So like that, people, started realizing that if you can go and orbit around Earth, we will be able to know more about the Earth as a planet itself. Otherwise, there is no way. Earth is such a big planet. If I have to sample, let's say, oceans of the Earth by ship or something, it will take hundreds of years. So to get quick amount of data about Earth's surface, and then they realize that communication can also be done. We can broadcast signal from one place to another place. So with all these kind of, dreams and visions in mind, the first satellite was envisioned, that is that Sputnik by Russians. And then Star Wars and all those kind of things. Later on, people started writing fictions, and then fiction movies were created. So space and then rising above the Earth. Even Socrates has written long back that if you want to know more about the Earth, you have to rise above the Earth. So these philosophies basically got people inspired to send objects into the space and do sensing of Earth's atmosphere, Earth's surface, and then do also signal transmissions, communication, and this is how this field has evolved over the last 50, 60 years. Okay.
So last question from the YouTube live, sir. That is,
Yeah.
in how many years will the Chandrayaan-4 launching from India into space?
Yeah, so I think we are planning a time schedule of 27, 28 right now. Okay, so we are in 25. So another 4 years, 3 to 4 years, you can see that the launch may happen. Right now, we are working, advanced work is happening. The mission has been approved by Government of India. Funding has been secured. The initial studies are completed. And now advanced work is going to be started on this mission. And we normally finish such missions in 3 to 4 years of time. Okay.
Yes, sir. Now I request Mr. Manish from the Zoom meet to ask this question.
Sir, good evening, sir.
Yeah, good evening.
Sir, is our country is going to build our own navigation system, sir, like Navik?
We have already built, as I told you, we have this Navik, which is a constellation of 8 satellites. So we are already building navigation satellites, launching them into designated orbit. So it has been demonstrated. There are some small glitches in this. Out of 8, only 4 satellites are currently active. So now in Navik 2.0, 3 more satellites are going to be launched so that the constellation can be successfully utilized for operational services. Okay.
Sir, and also the international space station also going to build by ISRO, sir.
Not international. Yeah, we are going to have our own Indian version of International Space Station. Okay. So that's called Bharatiya Antariksh Station. So that all project is also approved, but it is in the early phase, of configuration studies, etc. are being done. But yeah, idea is to have a similar space station like International Space Station, which will be totally operated by India and manned by Indian astronauts. Okay.
Okay, sir. Thank you, sir.
I now request Sai Shubham to ask this question.
So we can close by 6:30. I have.
Hi, sir. Firstly, thank you for being here with the KIYE and interacting with the students. And I want to start with my question with the student satellite, that is CubeSat. So how can someone build a student satellite and can send it to space in 2025? And
sir.
if someone can build a student
Hello,
satellite,
sir.
what is the purpose? What might be the purpose of building the student satellite? That is my first question, sir.
So
Yes, sir.
a lot of institutions are, or they have in past also built the student satellites. There are small satellites, basically for educational purposes. So we have a program office in ISRO. It's called Capacity Building Program Office. They basically directs or the colleges or universities which are interested in building such satellites and wants to launch a satellite, they can connect with our capacity building program office in ISRO headquarters. They will guide you that what type of satellites you can build and then how it can be launched, because it can be launched as a piggyback with the main launch. So all that information you can acquire from by contacting ISRO headquarters in Bangalore. Okay.
Okay. Because presently I'm working on hobby rockets. So this is actually prototype which I made of this one. So I just wanted to know how that can be done, because as of now I want to build just a hobby rocket, but in the future it might be a short distance communication or something like that.
So there is a complete process which is available for the launching of these student satellites, etc. As I told you, you can Google also, and then maybe through Naresh ji, we can also help you in connecting to the right people, which will they can guide you about this entire activity. Okay.
Sure, sir. Thank you, sir.
The last question for the section, Mrs. Manaswini, could you please ask your question?
Good evening, sir. Sir, a very short question is that in this rapidly evolving space sector, with all these private ventures jumping in, how is ISRO planning to keep India ahead, especially in areas like remote sensing, AI integration? Like how it is going to make India the top?
So the idea is basically that currently we are contributing only 2 to 3% of global space economy. Okay. And we have to scale it up. If you have to scale it up, you need more people and you need, larger ecosystem. And the vision is that by 2035, India as a country should contribute to roughly around 10% of the global space commerce. And that's why the space sector in all areas like space transportation, satellite building, instrument building, ground segment, data analytics, data processing, application development has been open to for private sector participation. And that's what has led to some 200, 300 young startup companies which are funded by, private capital or their own capital. They are working and they're doing excellent job and in very short span of time. So, and they are all nucleated around ISRO. ISRO is helping them in guidance, in in also providing and opening the test facilities to them, and any kind of teething troubles if they face. They are also there is an institution which has been created. It's called InSpace, which is a regulatory cum promotion body. So through InSpace, a lot of hand holding of these young startup ecosystems is also happening in space giants, and they can work not only for Indian space program, they can also start contributing for the space sector of other nations also by business arrangements. So this is the overall philosophy in terms of opening the space sector. And in various niche areas, the youngsters are most innovative people, and a lot of new innovations are also coming up with the private sector. Okay, I think, can you hear me now?
Yes, sir. Yes,
Yeah,
sir.
between I think it was lost. So, so your question was, how we are going to handle, and that's what I told you. There is an organization which has been created by Government of India called InSpace. They are basically coordinating along with all space, established players as well as young players. And one more thing which has happened, that the foreign direct investment (FDI) has also been open in different sectors on space. So, from foreign companies can come and then they can open their installations in India and then start contributing to space economy, because they can take advantage of our cheap, slightly less cost but skilled manpower which is available in India, because we have this demographic dividend and a lot of skilled people, good quality educated youths are also there in India, because many countries in Europe and in Japan and even in America, they are facing, the human resource crunch. So, which is not an issue in India. So, to, give, ample opportunity to Indian youngsters, the foreign direct investment in space sector is also opened up by Government of India. Okay.
Yes, sir. Thank you, sir.
Thank you so much, sir. With a heavy heart, I would say that we cannot take any more questions.
Yeah.
By this, I
Okay, thank you.
I would ask Ms. Chaitrika Biswal to give the heartful vote of thanks.
50 years ago, a tiny little satellite named Aryabhatta looked down on us from space. And today, we looked up and dared to dream big. Namaste and very good evening to everyone. I am Chaitrika Biswal, a fourth year student of Vignan Women's College. As we bring this inspiring celebration to a close, on behalf of Kalam's Institute of Youth and Excellence, I extend heartfelt gratitude to all the schools, institutions, participants, and young minds who've joined us today. This event wasn't just an event, it was an ignition of ideas, imagination, and possibilities beyond our atmosphere. We are truly honored to have Dr. Prakash Chauhan, sir, the director of NRSC, as our chief guest. Sir, your insights didn't just inform, they inspired. Thank you for sharing your vision and for encouraging the next generation for space leaders. To our enthusiastic audience, your energy made this session truly stellar. From interactive charts to engaging questions, you are the fuel of this mission. And don't worry, we've got your back. There is an exciting news before we sign off. We are launching a monthly space lecture series, 12 sessions every third Saturday, in collaboration with India's Space Agency to keep the spirit of space exploration alive all year long. And a massive shout out to the incredible team, tech, content, coordination who made this launch a seamless launch. And until we meet again, stay curious, stay limitless, and always keep looking up. Jai Hind, thank you from the stars.
Thank you. Bye-bye.
Bye, sir.
Thank you
Have a
so
good
much, sir.
day.
Thank you so much, sir.
Thank you, sir.
చెయ్యంత ఊపరా
Thank you, sir.
బాయ్ అని
Thank you,
చెప్పు
sir.
Guys, thank you so much. Yeah, thank you.